Today we will learn about pressure, temperature, and volume. Our question of the day is what happens when you heat up a stoppered test tube? Well, the relationship between pressure, temperature, and volume can be given by a seesaw, where pressure is on one side, volume is on the other, and temperature is in the middle. This means that if the volume of the gas shrinks or goes down, the pressure will increase. Alternatively, if the gas is given room to spread out, the volume increases or goes up and the pressure will decrease. If temperature rises, the only way to show that is by lifting the whole seesaw. Therefore, both pressure and volume can rise. For the seesaw to work, temperature must be in the middle, PTV. Remember, pressure is the force of pushing or squeezing, which can be measured in a variety of units. Standard pressures include 1 atmosphere, 101.3 kilopascals, 760 millimeters of mercury, or 760 torr. These values all represent standard pressure, 1 atmosphere, but in different units. Remember, temperature is the average kinetic energy of particles based on their atomic motion. In order to never divide by zero, all gas law equations use the Kelvin temperature scale. To get Kelvin, you add 273 to the Celsius measurement. The Kelvin temperature scale is the same as Celsius, but the scale has been slid upwards to exclude negative values. 0 Kelvin, or 0 K, is called absolute zero and indicates that no atomic motion is occurring. So, 273 Kelvin is 0 Celsius. These equivalent values represent the standard temperature. STP is a shorthand way of writing standard temperature and pressure, so 273 Kelvin and 1 atmosphere. Your classroom is probably somewhere close to standard temperature and pressure. Remember, gas particles are so far apart and the individual particles are so tiny that we ignore the space between the particles. Therefore, the volume of the container is considered the volume of the gas. Now, pause the video and try the show what you know questions. When you are done, you can hit play and check your answers. For numbers 1 through 5, we will convert the temperature in Kelvin to Celsius. Remember, Kelvin equals Celsius plus 273. So for number 1, we're going to take 273 and add 273 to get 546. For number 2, we're going to take 27 and add 273 to get 300. For number 3, we're going to take 100 and add 273 to get 373. For number 4, we're going to take negative 50 and add 273 to get 223. And for number 5, we're going to take 15.2 and add 273 to get 288.2. For numbers 6 through 10, we are going to convert from Kelvin to Celsius. Since Celsius can be negative, unlike Kelvin, we're going to subtract 273. So, for number 6, we start with 14 minus 273 will give us a negative 223. Number 7, we take 322 Kelvin and subtract 273 to get 49 degrees Celsius. For number 8, 785 Kelvin is going to be 512 Celsius. 100 Kelvin minus 273 will give us a negative 173 degrees Celsius, and 1650 Kelvin minus 273 will be 1377 Celsius. For numbers 11 through 14, we will fill in the blank with up or down to make the sentence true. For number 11, when volume goes down, pressure must go up. For number 12, when the temperature goes up, the volume also goes up. For number 13, when the pressure goes down, the volume goes up. For number 14, when the pressure goes down, the temperature also goes down. Notice how temperature goes the same direction as pressure or volume. However, pressure and volume are inverse. They go the opposite direction. For number 15, you will consider if the volume of a gas is doubled, what will happen to the temperature and pressure. Well, if the volume doubles, that means the volume goes up. The temperature will go the same direction. It will also rise. And the pressure will go the opposite direction. It will fall.